Start the recording. Looks like it's just you and you're trying to harm yourself. So let's see. Let me share my screen. Don't look at my screen. I'm sharing it not for you. I'm sharing it for anybody else that joins.
So don't watch the stream.
Don't. Watch the road. Check your mirrors. 10 and 2, right?
10, yes.
Okay. So you're going to miss this amazing animated GIF from Ghost in a Shell. It looks really cool, but you can't really see it right now because you're driving. Just rest assured it looks really cool, and it says chapter whatever. You know, it's really pithy and funny. And then it says processors and memory. Like it immediately acts like it's not going to tell you what the chapter is about, and then it tells you what it's about because it sort of wusses out on the whole too cool to say what the chapter's about joke.
That's all right.
That's what I'm about, is starting and abandoning jokes right away. So this lesson plan is a bunch of PowerPoints about processors and architecture. The quiz opens up today, and then we're going to have a different sort of build design this week. Last time I think we did gaming PC for a friend who's dumb, and this time we're doing a computational powerhouse computer for a friend who's smart but doesn't know anything about computers. For our calendar, you guys have had exam 1. We're going to go processors and memory this week. Next week, we're going to do power supplies and coolers. The week after that, we do storage. And then we'll take a test on processors, PSUs, and storage. Okay? Then after that, it's exam 2. After exam 2, we do I/O, which is, of course, input-output. And then we do a little build project, and we do a little customer service LARP role-playing. It's pretty wild. So then after that, we're getting towards the end of the semester. Veterans Day messes with this class a little. Thanksgiving messes with this class a lot. And then it's just about finals week, and we do our take-apart tests and escape. That's our general plan. Okay. So processing and memory, really the most important part of the computer, kind of defines everything else. Deciding which one you put in is the big decision. And the most popular, the most common are AMD Ryzens and Intel Core i7s, Core i9s. These are very similar products. They're both in a similar price range, similar power. They have a whole spectrum of low end, middle end, upper end. But, you know, so if you're looking at a Ryzen 7, there is an i7 that's very comparable. And the AMD is probably 10 to 20% cheaper. Actually, lately it's been more like 5 to 10%. They're very close in price. So we're going to be able to compare the characteristics of Intel and AMD against each other. We're going to talk about how we install and remove processors. We're also going to talk a little bit about memory and how and why we would upgrade memory. And you're missing all these great slides from the movie Face Off with Nicolas Cage and John Travolta. It's a terrible film. Like a Michael Bay film. It's so bad. It's good. Let's see. So the processor is installed on the motherboard. Very clear picture that you shouldn't look at if you're driving. This determines our power. Really, that's, if you think about everything else, yes, it determines price, capabilities, multiprocessing, blah, blah, blah. Really, it's just power. It's just like the engine in a car. We pick a V8 because we want power. We pick a V6 because we want some power, but also economy. We pick a 4-cylinder because we want economy. And we pick V10s or V12s because we have more money than we know what to do with, and we can afford a really good mechanic to mess with them all the time, and we love the noise they make. Let's see. So speed's important. Obviously, when you pick a processor, you're also picking a socket and accompanying chipset. You don't have a lot of say over that. Once you pick the processor, you're kind of stuck there. There'll usually only be 1 or 2 sockets, usually just one that it's available on. This locks you into certain architecture. You're choosing either Intel or you're choosing AMD or something else, like tablets and some other smaller computers have ARM. It's a little different. Then you have to think about multiprocessing. Is this a dual core? Is it a quad? Does it have 8 cores? Does it have 12 cores? This matters for performance and performance while doing multiple tasks. You have to think about what the computer is going to do for the life of its work. So we also think a little bit about memory cache, security, features of memory, support for virtualization, although they all support it. Usually you have to turn it on in the motherboard. Those of you that do the CCDC, the security stuff, you use virtualization because you don't like messing up your real computer all the time. So if you're going to break into a computer or you're going to deliberately infect a computer with a virus or try to infect it or whatever, you want to use a virtual machine, a fake temporary computer stored in a file. So a really powerful processor with a lot of memory makes virtualization much more pleasant because there's a performance hit when you boot up computer A and then run virtual computer B inside of it. That's slow. That's the computer's having to work twice as hard. So you want a big beefy guy. Integrated graphics or not is kind of a small factor. Most laptops have it these days. Okay, this is a map that we're not looking at if we're driving of the innards of a processor. You can see the data bus. You can see the ALU. We'll get more on that in a second. All these different parts. If this stuff interests you, if this catches your fancy, like actual architecture of the most fundamental and important computer products that are really just ruling the world right now, Rob has a whole class on microprocessor architecture, and you should check it out. And I can't think of the name of it right now, but if you email Rob Craig and say, I want to take your processor class, he'll put you into it. And it goes deep on the architecture, on the math, on the function, on the different types of processors. It goes a lot deeper than we're going to go. Like we're going to do like this week, take a quiz on it. It'll be on the next exam, and then we're kind of be done with processors. But Rob will go deep and teach you everything you could possibly want to know about them. And that's the part of the slide where a little school bus drives down the bus on the motherboard slide. See, but you can't look. You can look later if you check out the recording. Of course, making fun of Matt a little bit because he is in Discord listening while driving, not watching.
Yes.
Good man. So, I'm also going to have to, because you're here and you're not allowed to look, I'm going to have to visually describe this slide, which is a beautiful map of a processor with an animated GIF in the center of the insane clown posse who were famous for saying magnets, how do they work? So this slide is titled Processors, How Do They Work? And each processor has a couple of things built into it. First and foremost, it has an I/O unit, in-out, in with instructions and out with solutions. Then it has a control unit, which engages all of the other internal units and says, you do this, you do that. Then there's the ALU, which is the logic unit. That does the actual work. It does the math, produces the actual solution, hands it back to the control unit. So the I/O unit manages data and instructions entering and leaving the processor. Okay, so we're going to treat this, the analogy we're going to use is, this is Nick Fury. He gets a job, he hears about a problem, or he sees one coming, and he puts together a team to handle it, the Avengers. Then the control unit is Captain America. Manages all the activities, says who's going to do what, breaks up the task, gives everybody a job that they can do, or gives them the job that they need to take because no one else could do it. This is a managerial kind of thing. That's why we call it the control unit. It's in control. It's sort of the leader. Then there's the arithmetic logic units, or ALUs. Sometimes there's one, sometimes there's more than one. These perform all logical comparisons. These are the nerds that do the math. This is Tony Stark and Bruce Banner, or Shuri from Black Panther, who are math whizzes. They crunch the numbers, they produce the actual solution and give it back to the rest of the control group. Of course, there's also Doctor Strange, who would like to be included in this. So, some other basic components of processors. Registers are small holding areas. They hold very small bits of data. Basically, the ALU needs a little notepad to scribble things on while it does its math. And that's what registers are. The internal memory caches are like more and more and more notepads, calculators, slide rules, whatever the ALU needs to crunch the numbers it's crunching, it uses these small resources around it. And then the buses are how it connects to the other components to return the instructions it's given. So the arithmetic logic unit, sometimes on some boards it's divided into AU and LU, the arithmetic unit and the logic unit. It does these operations, it performs whatever the control unit gives it, and it stores instructions in the internal memory cache. So it's sort of like a super smart, super fast brain that can only think about one thing at a time. And then the memory cache, like the L1, level 2, level 3 caches, allow it to think about more than one thing at a time and therefore solve more and more complex problems. Here's a map that an engineer would draw if you said, design me a processor and show me how everything's connected to each other. So the processor doesn't actually look like this, but this is how you would design it if you're working for Intel and you're saying, boss, I got a new design for a processor. It's going to make us millions, and maybe I'll get a $3,000 a year bonus while the company exploits me. So off to the left, we see we have an internal memory cache. We know we're going to need that. That is connected to both the ALU and the control unit. Each of the ALUs has a separate register to itself. And then the control unit is the only thing connected to the I/O unit. This tells you the relationship of everybody involved. The I/O unit is the only part connected to the rest of the computer. So again, it's sort of running the show, but it hands off all of the medium and small decisions to the control unit. And then the ALU does the actual work. Now, the processor frequency is how we judge the speed. This is how many times per second the processor can think about something, can solve something. And it's zillions. It's an amazing amount. 1.2 gigahertz is thousands of instructions, billions of instructions per second. It gets out of hand in a hurry when you factor in multiple processors. We start to think about things like teraflops and other measurements. We're going to talk more about those pretty soon, especially with NVIDIA and Xbox and PlayStation 5 being essentially in now a teraflop war. It used to be a word that only nerds discussed, but now it's become like the horsepower of video game machines. And it's how much information can it crunch through? How complex of a game can it display? Hey, Daniel, how you doing?
Good. How are you?
Well, we're just doing some slides on processing here, and Matt is driving. Oh, I think he has left because he got to.
Peace out.
Yeah, well, he's either lost reception or he's arrived where he was going to go. So,
Yeah.
how you doing?
Not too bad. I have a bricked BIOS, which isn't fun, but
Oh no,
not
bricked
too
how?
bad.
What kind of BIOS?
Well, I have two BIOS on my motherboard, which is nice. I
Weird.
did a Windows update, and then my single line stopped working. Like I couldn't get post or anything.
Holy crap! So it's a dual motherboard?
Yeah.
And how old is it?
It's probably about 3 years old since I bought it.
That's right around the cutoff when they stopped
I'm
putting
just upgrading.
jumpers.
Yep.
Like, have you Googled to see if it has jumpers you could pull?
I have not.
Okay. We sometimes see that even the Dell takes forever to abandon an idea. But this year, Dell stopped putting jumpers on motherboards because if a BIOS password locks it or if it crashes during a BIOS update, you can essentially wipe it all the way back to original factory settings. If you find this one little jumper, you know what a jumper is in this
I
case?
believe so.
A tiny little piece of plastic that sits on two metal pins. It connects those two metal pins, and as long as they're connected, then the motherboard remembers whatever garbage it needs to remember. So the motherboard might be remembering that it has a password and you're not allowed to use it without that, or it might be remembering that the BIOS is totally foobarred and doesn't work anymore. So you pull that jumper, it forgets everything it ever knew. You boot it once without the jumper, then you shut it down and boot it again with the jumper, and suddenly it's back to out-of-the-box factory defaults.
I hope, because there's been a lot of issues since that BIOS bricked.
Well, I would first look at that. Look up the model number and the maker and say, is there a way to default this back to factory? Is there a jumper I can pull or some other? Sometimes there is no jumper and there's two little metal prongs. And if you touch, this is the craziest crap. If you touch a screwdriver to both those metal prongs, it sends a signal to just wipe.
Okay.
This is why we say in security, if the enemy gains physical access to our machine, the fight is over.
Yeah, I've tried to reflash the BIOS.
Okay.
I can't see anything. There's no
Can't see
post.
anything.
There's nothing.
All right.
So,
yeah, I would say jumpers are your only hope. Then replacement.
And
You're
then
looking for a weird secret hardware way to default it back to factory settings.
yeah, and then after that BIOS bricked, I had a weird BIOS light come on the motherboard that never came on before. So
That probably means it's just failing mid post. I bet if you Google it, this has happened to somebody else.
Oh yeah, for sure.
That's
I hope
always what I look for is where is the other poor soul that has already gone before me and suffered this fate? And
Well,
maybe they found a way forward.
I'm not too concerned about it
Right.
because it's only a first gen Ryzen board, and I'm going to upgrade to third gen or maybe fourth after their announcement.
Yeah.
So
Is
I'm
it
not really.
is it an AM4 board?
Yes, yes. It's AM4. It's a Ryzen 5 1600.
Okay. Okay. And you're keeping the processor or?
No, no. I'm just going to upgrade a processor completely.
Okay. Yeah. I'm looking at that too. I'm running a Ryzen 5 and an AM4 board, and it has some eccentricity to it. I really like their price and their performance. But frankly, with what NVIDIA is about to do to the GPU market, I'm kind of
I
worried
know.
about AMD.
I know. But I'm waiting for those benchmarks to come out before I hop on the
True.
NVIDIA.
Yeah. But if NVIDIA has gambled an awful lot on this. Like if they're lying, they're
They're
sunk.
claiming a
We'll
lot.
never trust them again.
No, they're claiming a lot.
Right. But if they have lied to sell
Yeah.
pre-orders, like the entire industry will slam dunk them into the Stone Age. They will be the No Man's Sky of graphics card makers.
Oh yeah, for sure. And personally, I wouldn't get the Founders Edition, anyways, or like pre-order it until like bugs and everything. I would wait till like the
Gotcha.
second wave.
Gotcha.
And
Yeah.
when designs for them get better because the heatsink and everything, like the
Yeah.
design
Mhm.
for it kind of blows.
Yeah. Well, I'm not going to upgrade because I'm fortunate enough that I have a 2080, and I haven't found anything the 2080 can't whoop as far as video games. Like it runs
When did you
everything.
buy it? Recently?
Last year.
Oh, okay. I was
I've
gonna
had
say
it for
you're
a
a sponge
year.
if you bought it recently.
No, it's no big deal. I mean, my son got a 2080 Super last June, but
Ooh,
there's no way. It doesn't matter.
yeah.
My threshold, because I've been doing this a long time, 20 years, I've been chasing the current technology as far as video
Fair,
games and other
same
stuff.
for me.
If it's if I get a month of use out of a thing before it's just replaced and obsoleted, I'm fine.
Right.
Basically, if I can't Amazon refund it, then I'm fine with it. Like I refuse to. I have too many times waited because I thought some new cool thing was about to come out and I didn't want to buy the old thing, and then the new thing sucked, and the new thing took forever,
Right.
or it wasn't that much different. It didn't really matter, and I could have just, I'm much more in the present now on technology. So, and
I
his,
get you. I just want a new NVIDIA card because my
I do
card's
too.
I'm kind of lacking.
Yeah, well, RTX was kind of a meh.
Right.
All right, well, let me finish these processor slides.
All right, sounds good.
Let's see. So, I'm recording all of this and I'll post it in case you want to catch up from the beginning. Okay.
Yeah. Sounds good.
So, talking about bus speeds, frequency multipliers. Yeah. Processors sold today contain ALUs and registers that do 32 or 64. That's sort of true. Everybody's pretty much going to 64 bits at a time. In fact, Microsoft is abandoning 32-bit stuff. It's old. It's sort of out of date. We don't really mess with hybrids anymore. And everybody's just agreed, the modern computing user, whether they are on a phone or on a tablet or a laptop, they're kind of demanding. Like all of our customers are like, why can't I have 12 Chrome tabs and Zoom and Word and YouTube like going at once and without my computer slowing down? We're like, oh, okay. Everybody seems to need quad core processors and 16 gigs of RAM. So nobody's going to want that old 32-bit stuff. And in fact, I looked this up today. This new version of Windows 10 that's just come out, pretty much abandoning 32-bit architecture. Finally. So the memory cache. Each processor has multiple levels. The L1 is the smallest cache, but it's the fastest and it's the closest to the processor. So if the processor has a small bit of information that it needs access to rapidly, L1 cache. If it's a little bit bigger and it can wait a little longer, L2, and so on, L3. RAM memory is like an L4 or L5 cache. It's huge compared to the L1, L2s, and slower. And it's across the motherboard several inches. These things make a difference when you're talking about billionths of a second. So this is just about performance. This is just about making sure the processor stays busy all the time. Because if the processor is idle, or if it's so overloaded that you're waiting on it, then you have a bottleneck. You have you've wasted some part of your money. if you don't support your processor with sufficient memory, storage, and software that enables it. Okay, let's see. Memory controllers built into the processor package. Yeah, the processor controls the memory. It decides what to put in there, what to load in. And yeah, adding memory can be a significant increase in performance. If you've got a customer who has 2 or 4 gigs of RAM and they are complaining about web browser tabs or multiple programs or video stuttering, Zoom stuttering, then you're like, well, maybe we should take you to 8 gigs of RAM because the operating system, whatever it is, but definitely if it's Windows, is gobbling up 2 or 3 gigs just from starting up. Just turning the computer on, getting to the desktop means Windows is gobbling a significant chunk of RAM, and there's way less than you think left over. So if your total system has 2 gigs of RAM, Windows is going to run like crap on it, especially as soon as you open anything. If you have 4 gigs of RAM, it's going to run fine until you open anything. If you have 8 gigs of RAM, you're going to be able to open 2, 3, 4 different applications and use the computer. It's much better. And then gamers and other power users, Photoshop people, video editors, they're going to want, 16, 32, maybe even more.
128.
128, let's go crazy. So the L1 cache is a primary cache. It's extremely fast. It's embedded on the CPU. It's built into it. The processor, if the processor had no cache, it could really think about nothing because you'd be like, hey, processor, 1 + 1 equals, and it would be like 1. And you'd say, no, 1 + 1. And it's like, plus? What? It would be completely stupid. And then if it has some cache, you say 1 + 1, and it's like, okay, I store this 1 in the cache, plus in the cache, 1 in the cache. Oh, the answer's 2. Easy. Like it can do the math in a billionth of a second, but it has to have some space to think about things. It has, otherwise it's like the guy in Memento with no short-term memory. So L2 cache, this is again just another layer. Hey dude, maybe there's a bigger chunk of things that you don't need access to quite as quick, store it here. And again, a bigger cache of things. So how well the processor manages its cache really dictates a lot of its speed. And as we were just discussing, they're about to come out with this new architecture. They're going to come out with this new motherboard, new video cards. The 1.0 of these things will have some inefficiencies because they're trying new stuff. They've got a new board or a new processor. They're trying out a new bus. They're going to mess with it. They're going to put lots of cache over here. They're going to skimp over here. And then they'll release a 1.0 product for $500 and everybody will buy it. And they'll be like, oh, well, the data we're getting shows that we didn't put enough L2 cache on this thing, and it's running 10% slower than it probably should, or 10% slower than we said it would. So the next version, they fix it. They change the architecture to manage that memory better and improve. That's why a 2.0, an RTX 2080 Super, is more powerful than an RTX 2080. They really just made it more efficient. They didn't add a ton of things to it. So a quad-core processor, if you had an engineer and you said, hey, design me a quad-core processor, just draw it on a napkin, this is probably what they'd show you. You can see that there's a memory controller, one memory controller. You can see that everyone is sharing an L3 cache. But then the core processors each contain their own L1 cache, and then they have their own individual L2 cache that they don't have to share with the other processors. So that's how the sharing relationship works. Because you figure you want them each to do these small operations on their own, but if it's a big operation, they can share a cache. This is a similar but simplified map. You can think of it like an apartment, like a suite of apartments. Like 4 people live in this apartment. Each one has their own bed, but they might have to share a bathroom, and they definitely share a couch. That's really it. That's processor architecture. You get your own of certain things, but then you have to share of other certain things. So Intel processors, the i3 is the cheapest, the lowest power, the lowest performance, but also when I say low power, it is the least powerful. It also requires the least electricity be run through it, which means it's the most efficient and generates the least heat. i9 is the opposite of this. It's very powerful. It can do the hardest work, the fastest, but it needs the most power. And the 1.0s of the i9, pretty widely known, they had some heating issues. Apple, who has heating issues of their own, combined their heating issues with the i9's heating issues, and the first i9 MacBooks are known to be just absolute lap melters. In fact, if you bitch to Apple and say this laptop is getting to be 200 degrees and I could cook an egg on it, it's not really a laptop. Apple will say, yes, we know it's not a laptop. Legally, it is what's called a portable, and you're an idiot for putting it on your lap. You're like, well, that's why I bought it. So that's the legal dance they do to get around their poor cooling of i9 MacBooks. It's quite irritating.
So I had two i9s come into the office one time,
Yeah.
and they like couldn't boot,
Oh,
and they both had turned them on and didn't properly cool them, so they died immediately.
they
Had two of them
died.
come in,
Wow.
they're dead.
That is not supposed to happen. Most modern motherboards, as you probably know, have a thermometer in them, and when they pass a certain temperature, they're supposed to cut off the power. But
Yep.
if the heat is already generated and then it has nowhere to go and you cut off the power to the fans, then the heat just sits there. And if it's enough to bake the motherboard or melt the processor, then that happens. That
Yeah,
sucks.
it was both. They were the ninth gens, like the new ninth gens that had just came out.
Yeah. No,
And-
I'm not gonna do. I'll never do any 1.0s on new processors, especially the top of the line where they're really pushing the performance envelope.
Right. Yeah.
That is your most likely to melt itself processor.
Oh yeah.
Whereas the middle of the road guy, your i5s, your i7s that have been out a long time, those are workhorses that will earn the money they cost for 6 or 8 years without issue.
Oh, definitely.
Yeah, that's awesome. It's terrible, but it's also kind of amazing. Do you ever watch those processor cooling contests?
Yes.
So funny. Just a
They're
bunch of insanity. A bunch of dudes, and it's all about teraflops, all about a performance measurement. It's like a drag race, and it is just as classy as a monster truck like tractor pull.
It really is.
It is a bunch of people who are, frankly, again, like the tractor pull, they're brilliant engineers. They're amazing at getting power out of a device. But then they have a whole bunch of other problems because they take an engine or a processor and they modify it into the stratosphere to where it's producing 2, 3, 4, 5 times the original amount of power and performance it was supposed to. And then they have heating issues. Then they have cooling issues. Then they have engines ripping themselves off of the frame in cars. And the processors, when they mess up, when they push it too far, they literally just melt. It's
No, yeah.
so cool. Okay.
It's
Yeah, we should maybe some point we may watch one of those videos and take a little quiz on it just because it's hilarious. And it's very applicable to this class of like overreach. Okay, so Centrino technology improves laptop performance. Debatable. It makes it cheaper. Wireless adapters are interconnected. This is obviously a book slide. Atom processors, another type of processor, low power. You're going to find that in netbooks. You're going to find it in tablets. You might find it in your phone. None of this needs to be memorized. This is all things you Google. But this is an example of the performance chart. You see the i3s down at the bottom. You see they've ratcheted up the speed of it because it needs so little electricity and it's only 4 cores. They ratchet up the speed. This is like your little Mazda Miata going 120 miles an hour. Like, yeah, no problem. It's a light little high performance, high efficiency or low performance, high efficiency engine. So we ratcheted up to crazy speeds and it still only takes, 90 watts. Cool. And then up in the i9s, we got 8, we got 16 processors. You can turbo it up to 5 gigahertz, but you probably shouldn't. And yeah, it needs a lot more to support it. And it's much more expensive. $500, goodness. AMD, same story. They have a $500 processor. It has 12 cores. And you see it's in a similar gigahertz range. The performance output is similar. The power consumption is similar, although the Ryzen 7 3700X looks to be extremely power efficient and economical. Occasionally, there's just a sweet spot where they really get it right. And that's usually the processor you want to go with. So in selecting and installing a processor, this is a normal task for the repair technician. You should be able to put a processor in a motherboard without breaking it. This is one of your final exam tests, is being able to do this. You should be able to exchange a faulty processor when you're sure that that's it or when you're trying to troubleshoot. You suspect the processor's the problem, so you find another one exactly like it, and you swap it out and see where the problem goes. Follow the problem. Or you just want to do an upgrade, like we were just discussing here. Daniel's going to do a motherboard and processor upgrade to his machine. How soon are you going to do that?
I do not know. I probably in like the next 2 weeks, maybe.
If you will, I cut this deal with Skylar, and you can have it too. If you videotape it, throw it up on YouTube, show me you doing it, then you can skip your take apart final with your turd.
Okay.
It will count for that. If I see you install a processor and the computer posts, like that requirement for this class is then met.
I'm okay.
Okay? So keep that in mind, everybody who's building a computer this semester, if you happen to. The turd computers from the class, or if you don't have access to that, or if you don't want to risk your own equipment, it's totally fine. That's what they're for. That's why Rob works so hard to get everybody a computer to experiment on. Okay. Matching to the system, of course. We use PC Part Picker to help us a little bit, but occasionally we'll do builds where we don't use PC Part Picker, so you need to have an understanding of how to match parts with parts. Okay. Designed to support, yep. Requirements and user needs. As we talked about our last build, the person had a Valve Index. They wanted to play video games. So the processor was medium important. The graphics card was really the most important. But in the next build we do, which we're going to do in lab tomorrow and Wednesday, depending on which section you're in, we're going to have a computational performance build, meaning the computer just has to have a monstrously powerful processor. It doesn't matter what the graphics card is. It crunches a crap load of numbers. And it's going to be a different kind of specification. You're going to have to look up what performance levels a certain processor can achieve. Should I go with the 3800 or the 3900? For this price, is it worth it? How much more performance do I get? And how do I measure that? And how do I then turn to the customer and say, this is the reason I chose this processor and the reason I think you should spend an extra $50. You have to be able to explain it. You have to understand why you're doing it. Let's see. Coolers. Installing a cooler is easier than ever. It used to be such a pain long time ago. There was sort of an industry-wide attempt to make general coolers, like a cooler that fits any motherboard. It was mostly a failure. They basically badly fit every motherboard. Nowadays, basically, if you get an AMD cooler for an AMD board, it's going to be 4 Phillips screws, or it's going to be a couple of clamps. It's not too bad. They usually have the thermal goo pre-applied. If you do your take apart final on your turd in class, you will have to both clean off the thermal goo and reapply it, which Rob Craig is insane, in case you guys didn't know. He has like a lifetime supply of thermal goo. There's like little teeny tubes of it that they give you with a new processor, they used to. That's not enough for Rob. He has the family size, which is like the size of a family size tube of toothpaste, and he has like 12 of them. It's amazing. He could literally take off and reapply all the processors in G102 100 times. Let's see.
You always keep that paste on you.
Yeah, you always keep some. I think Rob ran out of paste one time and it traumatized him. And so he just went crazy on Amazon. But this paste is just sort of a goop that has a high thermal reactivity. I forget what the physics thermal conductivity to it. The physics term basically means that it absorbs and sheds heat. So you smash this stuff on the processor. Literally, the top of the processor is waterproof. And you smash this liquidish gel-like goo on top of it. Then you smash the cooler on top of it. Because if the two of them are mashed on each other, then it's metal touching metal. They exchange heat at a certain rate. If you put this goop between the cooler and the processor, they exchange heat faster. Heat comes out of the processor more quickly into the goo, through the goo, and moves into the cooler quicker than it would without the goo. You can, if you ever needed to verify this, you could put your cooler on your processor with no goo and then run a stress test, and your processor will overheat and maybe damage itself and probably almost certainly shut down because it won't be able to shed heat as well as it needs to. Whereas you put the goo on there, suddenly the heatsink is getting much hotter. The fan is then pulling heat off of the processor more quickly. This stuff is crucial. That's why it's included. Someday I think maybe we'll invent or innovate beyond the need for it, but for right now, it's pretty crucial. There'll be either locking pins or screws. That fan that sits on top of the CPU cooler, it's got to plug in somewhere. It has to have power. It doesn't draw power through the goop or through the clamps. It has a separate power cord that is usually very close on the motherboard. In this picture, I should find a picture that includes it because it's kind of crucial. It's probably just outside the frame here somewhere. There's a little power connector and the fan is plugged into it. So then you mess with the BIOS and you get into the sort of trouble that Daniel's in this week. Okay, one of my favorite slides ever. Don't forget your CPU cooler. That's it. This slide is really rudimentary. It's from way back when I first started teaching this class, but I still love that slide forever. This is what the CPU cooling fan connector looks like up close. Usually 3 to 4 pins. Usually a little guide so that you can't put it on backwards because it has positive and negative poles that needs to line up. And then you plug that in, and when the motherboard turns on, power courses through these little pins, turns the fan on top of the CPU. Easy peasy. We pull heat off. So memory. Random access memory. We call it RAM. Holds data and instructions used by the CPU. Yes, it's like another level of cache, a huge level of cache that's much slower than L1 or L2 and much farther away, so it's a little slower, but it's still way faster than the hard drive, way faster than any CD drive or anything like that. So it's useful. This is typically when you run Chrome or run Skyrim or run Photoshop, it's getting copied. A significant chunk of the program and the data, the art, the sound, whatever, is getting copied into RAM for temporary storage because it's quicker to pull it off of there, for the processor to pull it from there than from the hard drive. This improves performance. We call these DIMMs, dual inline modules, because whatever. It's used to be just called RAM modules. Micro DIMMs on subnotebooks. We had a quiz question on that. We're good on that. And then the data path, the speed of the memory matters. The memory's got to match the motherboard. If it's DDR3, you got to have DDR3 motherboard. DDR4 matches DDR4, etc. They all have different physical specifications. The notch is in a different place, so you cannot use one and the other. Memory accommodates you as best it can. If it runs at 2600 and your motherboard only goes at 25, it will slow itself down. Let's see. Independent, yeah. You can see the changes here. DDR, the original DDR. Then we move the slot a little bit. Usually it looks like we just moved the slot. That's pretty much what we do. And my graphics card has DDR5 on it. The next generation of graphics cards is advertising DDR6 usually. And DDR5 will be on motherboards soon if it's not already. I should actually look that up. Could be a lazy butt and update my slide. Okay, double data rate. Again, this is just the concept of we made a thing, then we made it better, then we made that thing better, and now we're up to version 4, 4.0, 5.0. It's better, faster, more efficient. And honestly, the cost is about the same. 8 or 16 gigs of RAM has been $50 to $100 for years now, even if it's the newest, fastest type. So the manufacturers have gotten good at anticipating how many they're going to sell, which means they manufacture exactly the right amount, which means the cost is a little lower. DIMM speed measured in megahertz PC rating, yeah. And it's a function of the processor and motherboard speed. They all kind of have to sync up. Total bandwidth, yeah. We used to have these ratings for it. It was really obnoxious. You'd say, what kind of memory do I need for this Dell Optiplex 990? And they'd be like, you need PC2. And you're like, I guess that's DDR2. Yeah, that is DDR2. You'd look up and try to find the speed, etc. It's obnoxious. So, number of channels. In some cases, on some motherboards, there's a little bit of performance to be gained by putting certain sizes of RAM in certain slots. What the hell are we talking about? Well, in this picture, there's a black RAM slot, then a blue one. And you can't see it because it's behind this first chip. There's another black slot, and then another blue slot. You see the other one is that one. So this is a motherboard where dual channeling results in a speed gain. So what this person has done is put 4 gigs in the blue slot and 4 gigs in the other blue slot, and the motherboard likes that. It's designed to treat them as one big chip then, and it amounts to a very tiny speed gain. Single channel, it wouldn't matter. Memory controller communicates with 2 DIMMs at the same time. Yeah. Not sure if it doubles it. It's usually, if it's available and you have the chips to do it, you want to do it. If it's not, you make do. The other day, I cobbled together a garbage Dell at work for somebody who just had nothing else. And I cobbled them together a Dell with 5 gigs of RAM and a 100 gig hard drive. But it was a solid state hard drive. It was a terrible computer that I was able to make better by fishing out random chunks of RAM. And a total of 5 gigs of RAM is not something I've ever done before. But if it works, it works. And so it was like 2 gigs, 1 gig, 1 gig, 1 gig. Frankly, I wasn't sure if it would boot. But once it did, I was like, we're good. You're going to the customer. You're going to go do work. Have fun. Mr. 5 gig of RAM Dell. Quad channeling. Sandy Bridge does this. It's just something you want to be aware of when you're looking at a build and you're designing it. And again, when you're designing it, you're picking out every piece. So you should think, does this motherboard like dual channeling? Does it like quad channeling? If it likes quad channeling, then I should buy 4 gig chips instead of 2 8s. I should take advantage of the quad channeling and make them all go super fast together. Another nice diagram of dual. Yeah, you put 1 in this slot, 1 in that slot, and it treats it like one single 2 gig chip, and everything goes a little quicker. Triple channeling I have never seen, but it does exist. New laptops nowadays use DDR4. True. Doesn't see this cute little SODIMM, little laptop chip. Number of pins matters. Yes, of course. Same as ridiculous. So to upgrade memory means to add more RAM to a computer. Yeah, I still have people sometimes confuse memory and storage. The hard drive is storage. The CD drive is storage. A solid state drive is storage. RAM is memory. That's it. There's VRAM, which is RAM that's on the video card. But other than that, it's memory versus storage. How much RAM do I need? Well, typically these days you need more than 4 gigs. And you can look in your Windows Task Manager. You can Control-Alt-Delete and hit Task Manager and click Processes and look at your performance and see, actually, let's see, boom. And you can see the memory performance of your machine. You can say, oh, I'm running out of memory, or this app is using this much memory. OBS, Discord. I don't know why Epic Games is even running, but it shouldn't be. Steam I left running because I'm a sloppy dum-dum. So you can dig in the operating system and figure out how much you're using and then think, okay, is this the way I want to live my life with 4 different instances of Chrome running? Yes, because I'm slop. So I'm going to buy more memory to enable my terrible practices. Let's see. What's the motherboard's maximum? You're probably not going to have that problem, but we used to have that problem a lot. The RAM prices kind of came down suddenly, and everybody went, well, I want 8 or 16 gigs of RAM. And the motherboards were like, sorry, well, I was only designed to support 8. You could hit the limit, but that's not really a problem anymore. These days, we looked at last year when I taught this, some new Mac Pro came out, some Apple, and it supported just like a terabyte of memory. It was absolutely ludicrous. You couldn't possibly afford that much memory. Let's see. Installing new modules is pretty easy. The operating system, the 32-bit version, when it says x86, that means 32-bit. When it says x64, that means good, not terrible. So Windows, this is just sort of fundamental design of the architecture, is a 32-bit system couldn't recognize more than 4 gigs of RAM, which is part of the reason it has to go bye-bye. And 64-bit is the way. You can see this, that even way back on Windows 8 64 supported 128 gigs of RAM, which is a rare configuration. So really no problem there. Oh yeah. How much memory do I have? Quickest way, right click on this PC, my computer, open, look at the memory slots. You can eyeball it physically. You can examine the module. Let's see. Mine is, let's see. Do this. Do this. Properties. What's up? Windows 10. Right here it says 16 gigs. My poopy Ryzen 5 6 core 16 gigs. You can pull this screen up on pretty much any PC and get some crucial info on it. It's one of the first things you do as a technician when you're trying to figure out wacky stuff. Let's see. Ask somebody else. No, you're going to be the expert, although it's always fine to ask somebody else. Okay. How many slots? How many are filled? We already did. Basically, I already sprung this question on you guys in class. I made you open up your machine and tell me how many, where the memory is, how many sticks you had. And you can actually remove the sticks, and usually I'd say 70% of the time it's written on them how big they are: 2 gig, 4 gig, 8 gig. You can Google motherboard documentation. What's my maximum? Do I need to worry about channels? Let's see. Mixing unbuffered with buffered doesn't work. There's certain specifications. Usually the motherboard will warn you, but you don't really run into these problems very much. Okay, that's basically it. The quiz should be unlocked. You should all be able to take it. You all have 2 more days to take exam 1. Don't ask for an extension on exam 1 unless you have major medical issues and can prove it. I let you guys slide and give you tons of time for everything, but the exams have to be strict. 1 try, meet the deadline. You have 2 days to comply. I'm going to send you out a naggy email tomorrow saying, please take the test, because about 30% of you have not. Maybe you're just procrastinators. In lab tomorrow and Wednesday, depending on your section, we're going to do a psycholinguistics lab. Psycholinguistics is the study of language mutation and creation. Sorry, this is bothering me. I'm going to move this over. Thank you. And you will design a collection of computers that will run psycholinguistics software. Psycholinguistics software allows you to, say, create a language or try to predict how a language will mutate over time, which one of the guys I work with at SIU studies this stuff. He gets hired by space agency to talk to them about long trips to Mars or other locations, like how will language mutate? How will we ensure the fidelity of our communication with people who are on 10 or 20-year space missions, if it ever comes to that. It's cool theoretical stuff. And it'll be like, this is what the software needs to thrive. This is how much money you have. Tell me what I should buy. Similar to the other one. And yeah, basic requirements we'll go through. We won't be doing teams because teams are bad for COVID, but everyone will have the choice of going AMD, Intel, or being completely random. Not that there's many other choices, but that's pretty much it. You will have an area that we're going to deploy these computers in, and it'll say we need one of these machines in each one of these rooms, and here's your budget. So do me a combination build. You're basically going to build 4 computers, probably 4 identical. If you build different ones, I would need a really good reason why. So that's what we're going to do. And Daniel, thanks for hanging out. Thanks to Matt earlier, who had to run away.
Not a problem. I would also like to say the exams are due tomorrow.
Yeah. Yeah, I think I missed today. I think I'm going to make it close for both sections on Wednesday at 5.
Okay.
So you guys have I think everyone's going to have 2 days, and I have, I think I have 1 late joiner who I might extend it a few days for, but in general, the exams are the only thing I don't want to be flexible on. I will work with you guys on everything else. Extra credit. You guys are all doing well on quizzes. Everyone who's taken the test so far has done well. It's not crazy hard. It really just, all you need to do is take your time, Google the questions you're not sure about, and you should be able to get an A. As far as I know, no one everyone in this class that I have met and spoke to so far seems smart enough, organized enough, knowledgeable enough to get an A in hardware. So I expect all of you to get A's. Right? Right.
Right.
Thank you, Daniel.
Not a problem.
All right. Are you in my Tuesday or Wednesday?
I am in your Wednesday.
Okay. Hope to see you then.
All right. Sounds good.
Thank you, sir. Bye.